my name is Liz, and welcome to our SCX10 programming video. During this video, we will have live demonstrations of our SCX10 software, as well as some live programming examples. I'd like to introduce some basic motion types which we'll use during programming. An absolute move, which is represented by the syntax MA, incremental move, which is represented by the syntax MI, continuous operation, MCP, and MCN. MCP for move continuous in the positive direction, and MCN for move continuous in the negative direction. Mechanical home seeking, MGHP for the positive direction, and MGHN for the negative direction. Electrical home seeking, represented by eHome, and link motion, represented by link 0. Here we can see an example of an SCX10 linked operation motion profile. Here the resolution is set to 10 millimeters per rev, and the user units is set to millimeters. Here we can take a look at the overall motion profile. We want to go a distance of 10 millimeters at a speed of 10 millimeters per second. The next one is a 20 millimeter distance with a speed of 20 millimeters per second. And the third is a distance of 30 millimeters at a speed of 30 millimeters per second. Now let's see how we can change that to SCX10 syntax. Here we can take a look at the main program. DIS is the distance command. Distance 0 equals 10. So distance for the operation number 0 is set to 10 millimeters. Then we have distance 1 is equal to 20. Distance 2 is equal to 30. Then we have VRO equals 10. VR is the operating speed for the operation number 0 is set to 10 millimeters per second. Then we have VR1, which is the operating speed for the operation number 1 set to 20 millimeters per second. And VR2 set to 30, which is 30 millimeters per second. Next is the INCABS0- equals 1. This is the positioning mode for operation number 0 is set to incremental. And we also set the INCABS1 as incremental and INCABS2 as incremental. Next is our link operation. Link 0 is equal to 1. The operation number 0 is set to be linked. Linked 1 is equal to 1. The operation 1 is set to be linked. And link 2 is equal to 0. The operation 2 is set to a one-shot link. MI is to start the operation for number 0, and end ends our program. I'd like to introduce some other statements as well, such as conditional statements. The if statement. If input 1 is greater than 1, a condition happens. And if ends the if statement. For a while statement, while the input is less than 15, another condition can happen. And when ends the while statement. You also can have sequence control, such as call, which a call statement brings up a subroutine and RET returns back to the main program. A loop starts a loop sequence, and end loop and break loop, or end L and break L, are related commands of the loop command. I'd like to now introduce our SCX10 application example. We'll be looking at a ball screw application. Here we want to move from position 1 through position 2 to position 3, and then back to position 1. Here on the right-hand side, we have a chart which shows some basic syntax that we'll be using, such as the DIS for the incremental distance, acceleration, deceleration times, as well as our running velocity and our starting velocity, represented by VS, among others. Here we have more detailed information on our ball screw application, the load, the mechanism, our motion profile, and others. For programming, we need to know how to convert the overall motion profile into the actual programming syntax. Therefore, our motion profile is the most important. We want to take a total move distance of 10 inches, the total positioning time, we want it to be 2 seconds, and acceleration time at 0.5 seconds. We convert these values into SCX10 command syntax as follows. For the motor revolutions, you have to take the move distance and divide it by the screw pitch. So 10 inches divided by 0.25 equals 40 revolutions. To get our operating number of pulses, we have to take the resolution of the motor we're going to use, which is a 200 step per rev, times our 40 revolutions is equal to 8,000 pulses. Therefore, the total distance, or DIS, is equal to 8,000. Next is our pulse speed. We take the operating pulses and divide it by the positioning time minus acceleration time. Our operating number of pulses is 8,000 divided by 2 seconds minus 0.5 seconds. This gives us our pulse speed at 5,333 hertz. VR, our running velocity, is equal to 5,333 hertz. Acceleration time, which is represented by TA, is equal to 0.25 seconds, and deceleration time, represented by TD, is equal to 0.25 seconds. Here we can see the SCX10 flowchart based on the previous example. We want to move incremental, we want to dwell for 5 seconds, scan to see if input 2 is high, move to electrical home, and end the program. Here we can see the SCX10 syntax. The total distance, DIS, equals 8,000. Our starting velocity is equal to 100 hertz. Our running velocity equal to 5,333 hertz. Acceleration and deceleration time both set at 0.25 seconds. MI for incremental motion. Mend is wait for that motion to end. Then we want to dwell for 5 seconds. We want to create an infinite loop. And if input 2 is high, move to electrical home. Break the loop. End if ends the if statement, and loop ends the loop statement, and end ends the program. So now that we know the syntax for our example application of the ball screw, I'd like to now introduce the SCX10 demo. Here we can see the overall SCX10 universal stepping motor controller. It's connected to the 24-volt power supply next to it to power up the SCX10, as well as I'm communicating today via RS-232 communication. Next to that, I have a 15-pin I/O sub-D connector, which is connected to my I/O switchboard. That 15-pin can also be connected to a PLC. At the bottom, I have an 8-pin encoder connector. For today's purposes, I am using a motor with an encoder. And next to that, I have a 25-pin sub-D connector. That 25-pin connects to the driver I/O, which for today's purpose, I have an CRK Series stepping motor and driver combination connected to the SCX10. That 25-pin sends pulse and direction signals to the RK drive. I'd now like to introduce the SCX10 GUI software. Please allow me a moment to do some desktop sharing, and then we can take a look at some live examples. The SCX10 GUI software can be downloaded from our website. I've created an icon here on my desktop to connect. If to select the proper COM port. Depending on your PC, the COM port may vary. And you know you're successfully connected when you see the green LED down here. Here we can see the General Immediate Motion Creator for SCX10 Series. I'd like to briefly go through the 5 tabs up at the top, and then we can go ahead and do some programming examples. We have several different motion types, such as incremental, absolute, continuous in the positive or negative direction, go home in the positive or negative direction. We also have our motion parameters, like our distance, our starting velocity, running velocity, acceleration, and deceleration times. You can see as you type or click on these motion parameters, the command syntax automatically converts it over to SCX10 syntax for you. You have your start motion and your stop motion, and here we also have the profile graph of this motion parameter. At the bottom we have the I/O monitoring, you have alarm monitoring, position of the motor and encoder, as well as a hard stop. Next is our Program Editor tab. Here we have our online references. This is used to create or edit a program. This is the SCX10 syntax with a brief description next to it. We have basic motion parameters, some motion commands, linked motion, program flow controls, and so on. On the Program Editor tab, you can run a sequence from the sequence editor, so as you're creating, you can go ahead and test your program by selecting the Run Sequence Editor. You can view the SCX10 sequence directory to upload a program that's currently stored on the SCX10. You can also save a program from the sequence editor onto the SCX10. From the PC, you can upload it from your PC to the editor, or you can save it from the editor to the PC. You're also able to duplicate your data, for example, if you're programming multiple SCX10s with the same program, or if you'd like to have a backup and store all the programs onto your PC. We can now see how to create a simple program. Using the online references, you can double-click on these to move it over into your sequence editor. I selected the starting velocity. We'll select starting velocity at 500 Hertz. Next is our running velocity at 2000 Hertz. Acceleration time at 0.25 seconds and deceleration time at 0.25 seconds. Then we can select the motion type. We can do an absolute motion represented by MA, and we can do an absolute motion of 5,000. We can renumber our lines and do a syntax check. No errors are found. We can run the program we've just created by selecting the Run Sequence Editor. Run sequence now? Yes. We can now see the motor and encoder go to 5,000 pulses. We can save this program by selecting Editor to Syntax. This saves the program from the editor to the SCX10. We're going to call it sequence number 18, and we're going to call it Sample Pro. And save it. By selecting SCX10 sequence directory, we can now see that program 18 has been saved. When the SCX10 ships, it doesn't ship with anything in your sequence directory, but as you create your programs and store them, you'll build up your sequence directory. Next, I'd like to go to the terminal window. The terminal window, you can use the syntax on the terminal window. We're going to type in report, which is going to show us the overall I/O report, the remote I/O report, and the driver I/O report. We can see if you hit spacebar, it'll then continue on to our parameter report, position report, and alarm history. This screen can also be used to edit or create a program. Next is our Teach Jog screen. The Teach Jog screen is used for jogging the motor and teaching or storing that position. Here we can see I currently have 3 positions that are stored, but I'm going to start a new teaching jog by checking the box Teaching Start. You can teach by motor or teach by hand. The speed of the jog is based on the running velocity, which you can also set. Right now it's set at 2,000 pulses per second. We can see also by default the next position values appears, which is position 4, because position 1, 2, and 3 have currently some position values in there. You can jog by the minimum movable distance that's selected, or you can use the move continuous in the positive or negative. You can simply save these by selecting the arrow. It'll save that position as position 4 and prompt for the next position available, which is position 5. You can then later use these teach position values in your program. For the purpose of today's example, we will not be saving these, but if you were to save them, you'd want to save all position data to SCX10. Otherwise, it's going to give you an alert. So we will not save for today's purpose. Next is our System Configuration tab. We have System Parameters, I/O Settings, and Driver I/O. On the System Parameters, you can see the basic information like our user unit, distance per revolution, gear A, gear B, our motor and encoder resolution, pulse input mode, driver alarm, and so on. On the I/O settings, it gives you direct inputs and outputs, as well as remote inputs and outputs. For today's purposes, we can go ahead and configure the I/O. We can configure input 7 for an alarm clear. So if we were to get an alarm, we can now use input 7 to clear that alarm. We can configure input 8 as a panic stop, so if I wanted to stop for whatever reason, I can select input 8. And we can also configure input 9 as a start input. For the outputs, these are also easily configurable. You can select the output that you'd like to configure. We can configure output 1 as an end. We can configure output 2 as a run. And output 3 as an alarm. So once the motor has completed the motion, we should see output 1. While the motor is running, we'll see output 2. And if there were to be an alarm, we'll see output 3. In the I/O monitoring, we can see it throughout all the tabs. So we should see some movements of the I/O at the bottom of our screen here. Next is the driver I/O. Depending on the system you have, the SCX10 does have the ability to auto-configure to that particular driver, such as our AR series or our NX series. Today I'm connected to the RK driver, so it's not one of those options. So I have some manual settings. So since we did change the I/O settings here and did configure some inputs and outputs, we have to select Save and Reset to make sure everything gets saved to the SCX10. Notice that we did change the direct inputs and outputs, and right away we see output 1 as on because the motion has ended. So we're going to go back to the program editor and continue creating a program. We can go back to our ball lead screw application. I've already saved that program into our SCX10 sequence directory. And we can run this program. So we can see that the overall distance is now going to be 8,000. So we can see at the bottom that output 1 is on, which is our end output because the motion has ended. And output 2 is on because we're still running the program. The program is an infinite loop which is constantly scanning the input 2. When input 2 is on, it'll go to electrical home, break the loop, end the if, end the loop, and end the program. So I'm going to go ahead and activate input 2, which we should see down here, and we'll see the motor and encoder position move to the absolute position to the electrical home, which is the position 0. So we can see that input 2 was turned on, output 1 stays on because the motion has ended, and output 2, which is the run, turned off. So now we know that we've exited the program. Go ahead and turn input 2 off. And I'm going to go back into my SCX10 sequence directory and find our sample program that we started to create. I'll load it to the editor by selecting the Load Editor. And here we have the example program which we've created. We can edit this program and we can do incremental motions. So we'll delete absolute, which is represented by MA, and select distance for incremental distance value, and we want to do an incremental distance of 250. Then we need our motion command, which is move incremental. We can renumber our lines and do a syntax check. Then we can select the Run Sequence Editor, which will run our new sequence. So we should see the motor position and encoder position at 250 pulses. And I'm going to go ahead and rerun that. I'm going to run it a total of 4 times. So now our motor and encoder position are at 1,000 pulses. Next we can create a conditional statement. So instead of selecting the program 4 times, we can add a loop to our program. So we can loop this program 8 times. After the MI, we want to wait for the motion to end, and then we want to dwell for a specific amount of time. We want to wait 1 second, and then we want to end the program. We'll renumber our lines, and we'll do a syntax check. Missing loop, 1 error found. loop 8, but we're missing an end L. Every loop has to end with the end loop, which is end L. So now that we know that, we can simply add that into our program. Now we can renumber our lines and do a syntax check. No errors found, and we're going to go ahead and run the sequence editor. Notice output 1, which is the end output turn on and off, as well as output 2. I'm going to go ahead and rerun that program. Notice output 1 is the end output. It's turning on and off. Once the program is completed, output 2 will turn off. Next, we can create another conditional statement, an if statement. If input 1 is equal to 1, so if input 1 is high, then we want to loop 8 times. Otherwise, so else is an alternative if branch. So else, we want to move to the absolute position, so we have to find our MA command, 5,000. Renumber our lines, syntax check. One error is found, missing an end if. Every if statement has to end with an end if. So here we can include the end if. Renumber our lines and do a syntax check. No errors are found. So I'm going to go ahead and turn on input 1, which you can notice down here. Run the sequence editor. And we can now see the program is looping because the condition was met. Now if we turn off the input and run the sequence editor, note that the position of the motor and encoder is at 7,000 pulses. Since the condition is now not met because input 1 is not on, the motor should skip the entire if statement because it's not met, move to the else, move to the absolute position of 5,000. So we're going to go ahead and run the sequence. And we'll see now that the motor and encoder are both at 5,000. We can also run sequences just based out of the inputs and outputs. So we can go ahead and do standalone operation. We configured input 9 to be a start input. So all the I/O is off. I'm going to go ahead and activate input 9. And it moved the distance of 8,000. Since all the I/O is off, it defaults to sequence 0. So it's running what is currently stored on the SCX10 as sequence 0. Sequence 0 was our ball lead screw application, so I turned on input 2, and now the motor went back to the electrical home. I'm going to go ahead and rerun that program. And I'm going to go ahead and activate input 8, which is our panic stop. So I'm going to activate input 9 to start our program, and then I'll activate input 8. So I activated input 8, and now we can see that input 8 is on, input 9 is on, which is our start program, and we have an alarm. We can view the details of the alarm by selecting Detail, and we can see that the P-stop, which is the panic stop input, has been detected. You can clear it using the clear here. No alarms. Or I'm going to go ahead and rerun that and re-alarm it out again. So 8 and 9 are on. We have an alarm. We can view the details of the alarm and close that. We also set input 7 as alarm clear, so we can turn off input 8, which is our panic stop, and clear the alarm using input 7. I turned on input 7 and we can see that the alarm is now gone. And I can restart my program. This just shows the some basic motion profile examples, as well as a brief introduction into our SCX10 software. The SCX10 is $385 each. It is available to ship same day, and it'll work with any stepping motor or servo motor that accepts pulse and direction signals. Note that the 25-pin sub-D connector and 15-pin sub-D connector are not supplied. I'd like to thank you for watching our SCX10 programming video. If you have any questions, please feel free to contact us at 1-800-GO-VEXTA or email us at techsupport@orientalmotor.com. My name is Liz, and thank you for watching our SCX10 product video.